Hello and welcome to the podcast. I'm your host, Dave Albert. In this show, I talk about technology, building a company as a CTO and co-founder, and have guests to discuss their roles in technology and entrepreneurship. In this episode, I'm going to talk to you about Microsoft Azure's CosmosDB. You may want to listen to why Meta chose MongoDB, the episode quick take of this podcast. First, it probably isn't necessary, but if you're interested in why we chose Mongo over some other data store technology, that might help. I had basically decided CosmosDB was not going to work for us, but I went to a meetup last night and got a bit more of a better understanding of the proper way to deal with Cosmos. So I'm not sure if we've given up. To start off, I'll tell you a little bit about Cosmos. It is Azure's one database to rule them all. At least that's what they're going for. So it's a multi-model, which means you can use basically the API for SQL or Mongo or a graphing database. Gremlin, I think, is the syntax they use, or Cassandra, or Azure Tables. It is multi-region. It is, there's a low cost of ownership, sort of. It depends on how you architect it. But Microsoft basically deals with all the infrastructure, and you just have your connection URI and connection key. And it's basically immediately geo-redundant. You do not have to deal with backups or tuning. Of course, that means you also aren't really able to deal with backups or tuning. So you're at the mercy of Azure. But maintaining your own multi-country data center, data center in air quotes, to have database instances all around the world so that if one data center goes down, there's, overhead in that. So it kind of all depends on what your needs are. If you really don't need to necessarily tune your database, but that I don't necessarily mean just adding indices, or by maintaining data and those sorts of things, but actually like lower down to the choosing the right IOP level for the disks that the database is running on, and other elements like that, then this might be a solution for you. It's not perfect because there are a few things I'll get into in a little bit. I want to just go through some more of the notes that I took from the meetup. I can't read my own handwriting. So Azure is, or CosmosDB is moving very fast, and the documentation is usually out of date because the documentation can't keep up with the speed of the development, which it's a good thing that they're moving the development along for new features, more reliability, more making it more useful, but also it can make it harder to learn how to do something that you need to do because the documentation's a bit out of date. I mean, that's kind of the world we live in. Anything that moves quickly, the docs are almost always a bit behind. How many times have you gone to look at something and all the screenshots are from a version in the past? I know I do. So, like I said, it's multi-model, so you can have the API for SQL or Mongo. So that was very compelling for us, though it's not 100% there with Mongo. From what I understand, it basically is a replication of SQL, and there's very little that anyone I've spoken to or listened to or read from that uses SQL has issues with. But there are a number of things that are not the same as what you would hope for Mongo, so it's not really a drop-in replacement. So now, another reason it's not a drop-in replacement, the way the pricing works for Cosmos is you create request units. And a request unit is based on anything that happens. So, a read, write, I think storage is included. I'm not sure what the exact formula for identifying a request unit is, but from what I understand, 1K of one read is one request unit, and a write is more expensive. So the way that that it works is for every. So you have your database. So you create a deployment of CosmosDB. Within that, you create a database. So pretty much that's the same as what you would expect with any sort of databasing technology. Then you create a container. And a container can be thought of similar to what a SQL database would have as a table, or a MongoDB would have as a collection. Then within that, you have the entries. So that would be your documents or rows. Now, where it gets squirrely is that for each container, you have to specify the minimum number of request units, which is the minimum is 400. And 400 request units roughly equals out to about 24 euro per month. So if you basically take every collection you have and create a new container for them, you're looking at n times 23 or 24 euro. So like in our case, we have, I'm not sure the number, but quite a few small collections. And so we've got large collections, posts, users is getting larger. Hopefully that grows really quickly. We've got smaller ones, like lists. Those are growing, but not as fast as anything else. Collections, our collections collection, it's not growing as fast. Hopefully that also will grow quite quickly in the future. Feeds, that's growing, but not very quickly. Config, that's definitely not big at all. and quite a few others. So if we were to take let's say there's 10. If we take 10 new containers in Cosmos, that's €230 a month for our smallest collections from Mongo. And that's before anything grows, right? So that is impossibly expensive over the long haul. I mean, all of those could be handled by the smallest instance. So €5, right? So, or a €5, or $5 DigitalOcean instance, right? That could be served by that probably without any difficulty. So that's out. The way this is solved is by not thinking of a container as a collection, but more as a store that your collections can go into. So here's where I'm starting to rethink our strategy and if it might make sense. I have definitely not decided to do this because I know we've got a number of places where we do Mongo lookups, and I'm not sure we would want to re-architect that, but we still have to make our geo-replication strategy much more robust, and not maintaining infrastructure is often a good way to go. Often, not always. So you can have, some sort of, each container should have a partitioning key. So what we could do is have some formula that would create the collection type and some other element to partition it, because if you get over 10 gig, then the partition falls over. So if a partition gets to be over 10 gig, they can't replicate it, and it basically stops working the way you would hope. So you need a good way to, so the same way if you were going to shard, basically you have to shard it. But because you're sticking more than one collection in a container, it has to be logical how you can split those up. So sure, we could do each collection as a partition key, so the collection type, but some of the collections will outgrow, and that isn't useful. There's no reasonable limit. It's basically unlimited. Now, obviously, there's an asterisk on that, but one of the guys that talked last night said that he has basically 4 million keys. So really doubt you need to worry too much about having too many keys. I mean, I don't think you would want each individual entry to be a key. That doesn't make much sense. So if you have the collection type and then something else as the key, it doesn't have to be the same for each one. So like it could be collection type users and country. Now, I don't know. I haven't thought about, the actual implications of that, whether it would outgrow per country the 10 gig limit. But that might work. Or it could be, well, I guess what we could do is something like users underscore country underscore specialty. Right? So I really doubt that we're going to outgrow 10 gig of specific specialties in a specific country. So that might work, or something similar to that. Yeah, okay, that might work. So it can be less expensive than trying to maintain, multiple 3 or 5 different data centers with different Mongo connections, maintaining all the backups, the disaster recoveries, plans for each of those instances in each of the countries. So perhaps if I were starting from scratch, I would seriously consider using it. We are, we've been live for quite some time. We're trying to finalize a few bits of the product, and it makes more sense to focus on that right now, but there's a risk by not having the geo-replication completed just yet. So I'm not positive. A few more bits that might be interesting about Cosmos, that by default, everything is indexed. Every field is indexed, which has a cost to it, but means that you don't have to figure out what to index. So as you're growing, that can be really useful. I know that we've had times where we've had to go and re-index data because we've run out of, or performance degraded so poorly, became so poor on some queries that, okay, we have to create a new index. That takes time. That creates a burden on the server. It takes processing and memory to build those indices, and that can have a negative impact on even your testing environment. So we've had our Mongo server fall over before. Not Mongo's fault. It's because it's a small instance, because that's all we need. And it was building a really large index, and you throw, your typical load at it, which normally brings it up to 70, 80%. And then if it's already at 90% trying to run the new index, then it's not going to perform very well, and it actually crashed. We were able to bring it back up, no problem. But, it's just something to think about, is that if everything is indexed, you don't have to think about them too much yet. So it's kind of the same nice, unique bits about schemaless, is that you don't have to necessarily know while you're developing and growing the product every bit of how it's going to work, because, as you are, no pun intended on the Azure, as you are developing it, your understanding of it's going to change. So that was interesting, but you can change what is indexed in each container. So that's another thing to consider, is that that each container has the same indexing rules. So you may need to think what that means. So then what you can do is, to ensure that you're not outrunning your request units, you monitor for 429 errors. This is out of RUs, I think. I'm not sure the exact wording of the error, but that's what it means, is that you've run out of request units and it's going to be throttled now. That can be mitigated a little bit by using the Microsoft SDK for connecting to Azure. I think so. C# has everything. I think Node has everything. So the Microsoft's Azure's Cosmos NPM module, or from NuGet for C#. I know there were a few others. They weren't all as fully fleshed out. There was something in Golang. I can't remember how deep that went, but it's definitely a good idea. It already takes into account backoff and circuit breakers and all the things that you would want to ensure that you didn't lose data done for you. You could, of course, do that yourself. One of the guys last night did a demo just using PowerShell. That was, it looked like a bash script, but in PowerShell, that basically did it by connecting to the REST API. So you can use anything. The SDK specifically by Microsoft has some really useful elements to make sure you don't lose data. Of course, the key partitioning, as I mentioned before, it looks a bit like it could become a giant quagmire, because you can't change the partitioning key. You'd have to basically extract all your data, redefine what your partitioning key is, and then import all your data again. So that can be, a serious problem if you outgrow your partitioning key. So you definitely need to think long term on that. So I'm considering if we might do that. And the strategy I probably will use will be with Azure Functions. That's the serverless. So like AWS Lambdas. I'm not sold 100% on serverless. And it's not about, I am in love with the idea of serverless. It's the actual implementation and how deployments work. And it's the same thing with microservices, right? Microservices are great when they fit the need. If you've got a small team all working on one application at the same time with very little clashes, merge conflicts, basically, I think, this is not from experience, this is from thinking about it long and hard, I think, good grief, sorry. I think the benefits do not outweigh the cost. And by cost, I mean the cognitive load cost. You have to think about things differently. It's harder to test the integration locally. It may be even hard to test anything locally. I haven't looked at the state of local testing of serverless recently. It was doable. It didn't seem simple and intuitive when I looked into it. But I might consider defining what our container key partitioning strategy would be, and then slowly move different elements over and use serverless functions to connect to that. And then our current API could basically be a API gateway type thing, where instead of connecting to the model based on connecting to Mongo, it would still connect to the model, except it would pull it from a request to an Azure function. So I think if we move, that's the way we'll go. It would take us way too long to do a big bang move, where every separate, well, I guess we could still do that, directly having the model connect to Cosmos instead of connecting to Mongo. That might work. I don't know. I can't tell if I'm trying to inflict serverless onto the application or if it's the right move. I need to do a little more deep thinking. That's kind of what this podcast does for me anyway, is as I start to have to say my thoughts out loud, it begins to clarify my thinking. So perhaps it would be even more interesting if I had a co-host who were to ask questions about what I'm saying, since the listeners can't ask me the questions in real time. That might be useful. Anyway, Cosmos might be perfect for you. There are some complexities in the way it's set up. It seems amazing not to have to deal with the infrastructure. I say that as an ops guy, right? So I've said before, I'm 51% ops and 49% dev. So I'm a sysadmin at heart, but also a coder, right? So I like maintaining infrastructure, but when you're trying to build a product and a team at the same time, something's got to give, right? So the hands-on ops is one of the things that maintains things from falling over. It prevents disasters and problems, but it doesn't move the product forward. It's a risk, because if you can't trust your infrastructure, then you can't trust your application, so nobody's going to use it. But it doesn't make it better by making sure that it's more reliable. Yeah, I heard it. That didn't exactly make 100% sense, but I think you know what I'm trying to say. You collectively. I don't know, but I'd love to hear your thoughts. So as always, you can email me, podcast@dave-albert.com, or on Twitter @Dave_Albert. Bye.
Until next time, remember, any sufficiently advanced technology is indistinguishable from magic.